We will now see very important properties of Laplace transforms that result of applying integration by parts to the definition of the Laplace transform. In this integral transform, we will let f be function u and the exponential be function v prime. This means, of course, that v will be the primitive of this in order to t, which is the integration variable. This, since t is going from 0 to plus infinity, is equal to the limit as t goes to infinity of this product here minus this product here evaluated at t equals 0. This integral here is by definition the Laplace transform of this function, the derivative of f, the function we began with. This limit here has got to be 0. Why? Because this exponential is going to 0 as t goes to infinity. We might think that f could be going to infinity too. But remember that if this Laplace transform exists, then if f goes to infinity, it cannot go to infinity faster than this exponential is going to 0. Otherwise, this integral would not exist. Consequently, this limit really has to be 0. We will now rearrange terms and conclude that the Laplace transform of this derivative here can be obtained as the Laplace transform of function f, which we usually denote by f of s, multiplied by s minus the value of the original function at 0. Let us see an example of application of this expression. We know that the Laplace transform of e power minus t is equal to this fraction here. Consequently, the Laplace transform of the derivative of this real valued function of a real variable, which is minus e power minus t, has got to be this Laplace transform multiplied by s minus the value of this function at 0, which is 1. This expression can be applied repeatedly to find the Laplace transform of the second derivative. We find it as the Laplace transform of the derivative of the first derivative, and so on and so forth. We will reach the following results. The importance of this result cannot be overstated. We see that the Laplace transform of a derivative becomes a product by variable s. As we will see, this means that we can transform differential equations into algebraic equations.